In 6a, we're asked to figure out the distance between a point and a line, but here we're doing an R3. The challenge with R3 is to get our normal, we need to get a cross product of two direction vectors. Now obviously we've got one direction vector right here, but to get my second direction vector, I need to get my points P to Q, or Q to P, or perspective, and figure out another direction. So 1 minus 1 is 0, 0 minus 2 is negative 2, and 0 minus negative 1 is 1. Okay, now I can get my normal. My normal will be, and it doesn't matter the order you do this in, you can do PQ and then S, or S and then PQ, but either way, we got to take the cross product of those two things. Okay, so negative 2, 1, 0, negative 2, and negative 1, 2, 2, negative 1. Okay, so we get negative 4 minus negative 1. We get 2 minus 0, and we get 0 minus negative 4. So our vector is negative 3, 2, and 4. If you did yours in the other order, you can get the same values, you just have the opposite directions, right? So what is our distance? Our distance is our cross product, and the magnitude of the cross product. So we'll get the square root of negative 3 squared, plus 2 squared, plus 4 squared, all over the magnitude of our direction vector. 2 squared plus negative 1 squared plus 2 squared, which gives us on top root 29, on the bottom root 9, or just 3. In 7a, we're looking between two parallel lines, and again it's an R3, so we're going to have to figure out, well, we've got one direction vector for sure, we can use this one, it's the same one twice, and we're going to need one other direction vector, so let's call it AB. And if we do our vector subtraction, we'll end up with negative 2, 0, and 2. If I want to find my distance, I'm going to need my cross product idea again, right? The normal, if you will. It's what we're always producing. We make a cross product here. So just to show it this time, my distance will be the magnitude of, or the, we'll call it the magnitude of. Okay, so what do we got? We got 0, 2, negative 2, 0. And my parallel lines are both going 1, 2, 2, 1. So on the top, our cross product is 0 minus 2, 4 minus negative 4, and negative 2 minus 0. And we're going to take the magnitude of that. We're also going to take the magnitude of our direction vector, which was 2 squared, 1 squared, and 2 squared. So on top, we end up with the root of negative 2 squared, 8 squared, and negative 2 squared again. On the bottom, we have the root of 4, 8, 9, which is just 3, right? So on top, we get 4 plus 64 plus 4 again, which makes root 72. On the bottom, we get 3. You can leave it exact or change it with your calculator.